Peter's a bit of a tool and he doesn't even know how to use Git.
Okay.
Chris expects so much from me. Like I don't even know what I'm supposed to do. He's just like, just get it done. And I'm like, seriously? Tell me exactly what I need to do. And
Miriam thinks she's so cool.
Yeah, so the man Sam, man, what can I say about him? He always wears Nikes to every meeting we come to, and yet everyone else does not. If only he knew more about style.
Oh man, that guy's show, like, dude, he never talks to us. Like, it's so frustrating. Like there's nothing that I can do that will make him talk. I talked about playing video games, I talked about cars, I talked about everything, and he still doesn't talk about coding. Someone help me. This is what teams are like in real life, but not this team. This is Tether, a team of cooperation and passion. Here are some of the stuff we are currently working on to improve our system.
For the class diagram, Tether will be using 3 different classes. First up, Tether will have a user class which pertains to the person that is using the app. The attributes will be their GPS location and their unique user ID, which will be used to store and query the user information from the database. The AR Anchor class is derived directly from the ARKit/AR Core API and contains an add function to add the AR Anchor into the real world onto the user of the car. This anchor will then house a 3D marker that will guide the user back to his or her car. The user view class applies to the home screen of the app and houses the user interface. Once the app is started, an instance of a user will be created which will store the user's location. The user will then be instructed to tap on the screen to place a 3D marker on their car. A retry button will be visible to the user to remark their car's location if they are unsatisfied with their initial placement. For optimal performance, the GPS location will be stored in a database instead of using the memory of the phone. Once the user needs to return to the car, Tether will query the stored GPS coordinates from the database using the user's user ID. The 3D marker will be rendered at the GPS location of the marked car, which the user will be able to see through their camera.
For our app, the database we are using is Firebase, which is a real-time cloud database. The database will use a GeoFire add-on, which allows the user object to store the location of the user's car, the user's current location, and even edit their location by the phone ID key that is associated with the user. And this is done by passing the phone ID key to a set location method, which returns a string that contains both the longitude and the latitude coordinates.
In our use case diagram for the Tether app, we have one actor, which is the Tether user, and we have 4 different use cases. The use cases are edit cart location, store car location, collaborate GPS, and view car location. So let me give you a hint of what each use case does specify. First thing the user does is goes to the store car location, and when you open up app, it goes directly to the store car location use case. In that, it collaborates the GPS coordinates and your user completes its functionality for storing the car location correctly. In this store car location, you might have an access to edit your car location just in case if you did not put in the right location for your car. After the completion of the store car location, the app traverses to the use case of view car location. In view car location, it updates, uses collaborate GPS each time in store car location. At the end of the use case, we see that if the coordinate of the car location and the person location match, then the Tether app ends and it goes to the main screen.